Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In our last lecture, we derived a relation for Newton's law of gravitation, and at the end, we raised a few questions like, if every body attracts every other body, then why is this force not felt? Our second question was, does an apple attract the earth? If yes, then what will be the magnitude of this force as compared to the earth? Now let's try to answer the very first question. For simplicity, assume that there are only two objects on the surface of the earth. One is the person, and nearby him the chair. According to Newton's law of gravitation, every object attracts every other object. Therefore, there will be a force of attraction between the person and the earth. Similarly, there will be a force of attraction between the chair and the earth. Likewise, there will be a force of attraction between the person and the chair. Since the mass of the earth is much greater than the mass of the person and the chair, therefore, the force of attraction between the person and the earth will be very greater than the force of attraction between the person and chair. Similarly, the force of attraction between chair and earth will be very greater than the force of attraction between person and chair. Hence, the force of attraction between the person and chair is not felt. Let's try to answer it in another way. The value of universal gravitational constant is 6.673 times 10 power negative 11 Newton meter square per kilogram square. This value is too small, and gravitational force is the weakest force among the fundamental natural forces. Therefore, it cannot be felt in case of small masses. However, in case of huge masses like the earth, sun, and other heavenly bodies, it can be experienced. Our second question was, does an apple attract the earth? If yes, then what will be the magnitude of this force as compared to the earth? Since every object attracts every other object, therefore, certainly the apple will attract the earth, and the magnitude of this force will be equal to the weight of the apple. Both the apple and the earth will exert each other with the same force. According to Newton's second law of motion, F is equal to ma, or A is equal to F divided by m. Since the mass of the apple is very small as compared to the mass of earth, therefore its acceleration is experienced. But the mass of the earth is very greater, therefore its acceleration not be felt. Hope you got the answer. Thanks a lot.